Hi, this is a little video showing how to solve a logarithmic equation. Okay, let me get my handy little dandy pen going here. Okay, directions. Solve the equation. Show all work around answer to 4 decimal places. Whoa, look at this problem. It is kind of big. It looks really big, doesn't it? Log to base 4 of the quantity 9z plus 5 minus log base 4 of the quantity 2z plus 2 equals 1. Whoa! All this on the left-hand side is just equal to 1. Isn't that pretty amazing? A whole bunch of stuff to just say it's 1. Huh. Well, let's take a look at two of the things we're going to use. And what we're going to use is the quotient property of logs, and that goes like this. Log base b of the quantity m divided by n is equal log base b of m minus log base b of n. Look at that. That's kind of the form that we have here. We have logs to the same bases separated by a subtraction sign, by a minus sign. Now, the other thing we're going to use is the definition of logs. And look at this. I love this graphic. It clearly shows how to bounce back and forth from the exponential form to the logarithmic form. And it's clearly laid out in color-coded symbols using color-coded lines and numbers. Great. It makes life a heck of a lot easier. So let's apply these two things right now. Well, the first thing we're going to apply is the quotient property. So using the quotient property, we can rewrite this as log base 4, the quantity 9z plus 5 divided by 2z plus 2 equals 1. Now we can use the definition of logarithm and do this. So now we can say 9z plus 5 divided by 2z plus 2 equals 4 to the first power. And that's just 4. So now we just have a standard kind of equation that we know how to solve. We're going to multiply both sides by 2z plus 2, 2z plus 2 over 1 times 2z plus 2. And of course, these puppies will just cancel out. We'll be left with 9z plus 5 equals, remember, 4 to the first. Anything raised to the first power is itself. 4 to the first is 1. 1 million raised to the first power equals 1 million. Well, I'm running out of space for zeros. Okay. So 4 times 2 is 8. 4 times 2 is 8. 8z, so minus 8z minus 8z minus 5 minus 5. And we get z equals 3. So that's what we end up with, an answer, z equals 3. But how do we know that? Well, how do we know that that's correct? Let's do the check. Let's just make sure that it is accurate, okay? So we're saying that z is equal to 3. I'm going to use this form here. It'll be a little bit easier to work with. So we'll say log to the base 4 of 9 times 3 plus 5 over 2 times 3 plus 2 is it's still all equal to 1. It hasn't changed. Well, 9 times 3 is 27. 27 plus 5 is 32. So we have log base 4 of 32. And 2 times 3 is 6. 6 plus 2 is 8. It's looking good. 8 divided by 8, or 38 divided by 32 divided by 8 is just 4. So we end up with log 4 equals 1, and apply our definition of logarithm, and we end up with 4 to the first equals 4. Therefore, 4 equals 4. So it checks out. Therefore, when z is equal to 3, then all this gobbledygook on the left-hand side, when you Condense it down is just equal to 1. That's just another way of saying 1. Amazing. Okay, I hope you found this helpful. Remember, use the pause button. If there's something that you don't quite understand, use the pause button, think about it, and then press the play button when you're ready to go on. Okay, bye.